Hello, welcome to Enmak Academy. In today's lesson, we are going to be looking at limits. Let's start with this example. Let's say a function f of x equal to x squared plus 1 all over x minus 1. Okay, so in this particular example, we're not given where it is approaching, where the value is approaching. So if you look at the denominator here, this is x minus 1. We can see that when x is equal to 1, the whole function becomes undefined. So we can say that, so let's say this is 0 and then this is 1. So we can look at values as it approaches 1 from the right hand side and also as it approaches 1 from the left hand side. So for the left hand side, we pick values. So f of x is equal to x squared plus 1 over x minus 1. So since we are approaching 1 from 0 to 1, look at this, from 0 to 1, we can pick values like 0, 0.5, we can do 0.9, 0.99, 0.999, and then let's say 0.9999. Okay, so when x is equal to 0 in this function, that means that wherever we see x, put 0 there. So that will be 0 squared plus 1 over 0 minus 1. And that will give us negative 1. If we substitute x to be 0.5, 0.5 squared plus 1 over 0.5 minus 1, we get minus 2.5. How about 0.9? When we substitute this, we should get minus 18.1. And then 0.99 will give us negative 198.01. 0.999 when we substitute in this value should give us minus 1998.001. And then 0.9999 into this function should also give us minus 1998.0001. What conclusion can we draw from here? We notice that as x gets closer, closer and closer to 1. So why do you say as s gets closer and closer to 1? Look at the values we selected. We have 0, 0.5, 0.9, 0.99. So we are getting close to 1 over here. So as x gets closer and closer to 1, f, which is a function, f of x, becomes smaller and smaller without a bound. Because these values get smaller and smaller, minus 19998.00, and that's a very small number. So as x gets closer to 1, f becomes smaller and smaller without a bound. Let's check for the right hand side. So using the same function for right hand side, so let me rewrite the function here. The function is f of x equal to x squared plus 1 over x minus 1. So for right hand side limits, so we can draw a table here where the function is f of x equals x squared plus 1 over x minus 1. So now we are getting to 1 from the right hand side, so we can select numbers like 1.1, 1.01, 1.001, 1.0001, like we indicated earlier on. If this is our line, so we have 0 here, and then we have 1, and then we are getting to 1 from the right hand side. This is what we mean. So it means that the value should be greater than 1, because we are approaching 1 from the right hand side. So that's how come we have 1.1, 1.01, 1.001, 1.001. We are going to substitute these values of x into this function. When we substitute 1.1 into this, the first one should give us 22.1. 1.01 should also give us 202.01. Then 1.001 will give us 2002.001. 1.0001 into the function will give us 20002.001. What conclusion can we draw from here? We can also say that as x gets closer and closer to 1, as x gets closer and closer to 1, the function f becomes larger and larger without a bound. So as x was getting closer and closer to 1 from the left hand side, we saw that the function got smaller and smaller without a bound. Now as x is getting closer and closer to 1 from the right hand side, we are seeing that the function gets larger and larger without a bound. So this shows that the function f of x squared plus 1 over x minus 1 does not have a limit. Or you can say the limit of f does not exist, because from the right hand side the number gets larger and larger, from the left hand side it gets smaller and smaller. So we can say that as x approaches 1, f decreases or increases without a bound. Alright, so we'll take a look at a different function to see how limit works over there. Let's consider this function. Let's consider the function f of x equal to x squared minus 1 over x minus 1. So over here too, we'll take limits as x approaches 1 from the left hand side and as x approaches 1 from the right hand side. So for left hand side, we can use values like so let's try the function here. F of x equals x squared minus 1 over x minus 1. So what values are we selecting? Now x is approaching 1 from the left hand side, so we can say 0, you can use 0 0.5, 0 0.9, 0 0.99, 0 0.999, and then 0 0.9999. So there's a point, so you have 0, 1. So we look at from the right hand side and also from the left hand side as x approaches 1 from the left hand side. So that's how come we have 0, 0 0.5. So the numbers are between 0 and 1. So you have 0, 0 0.5, 0 0.9, 0 0.99, like that. So let's substitute. 0 into this will give us 0 squared minus 1 over 0 minus 1. And that gives us positive 1. 0 0.5 into this function will give us 1.5. 0 0.9 into the function gives us 1.9. 0 0.99 will give us 1.99. 0 0.999 gives us 1.999. And 0 0.9999 gives us 1.9999. What conclusion can we draw from here? So from this table, we notice that as x gets closer and closer to 1 from the left hand side, f, which is a function, also gets closer and closer to 2. Closer and closer to 2. So we can see as we are moving down this way, as x is getting closer and closer to 1, you can see that gradually we are also getting closer and closer to 2. Let's see what happens when we are approaching 1 from the right hand side. So from the right hand side, let me still write the function here so we can follow. So we have f of x equal to x squared minus 1 over x minus 1. So from the right hand side, so here to select some values. So f of x is x squared minus 1 over x minus 1. So since it's approaching 1 from the right hand side, we can select values like 1.5, 1.1, 1.01, 1.001, 1.0001. Yeah, let's take these values. Now let's substitute 1.5. So f of 1.5 will give us 1.5 squared minus 1 over 1.5. And that gives us 2.5. 1.1 will give us 2.1. 1.01 gives us 2.01. 1.001 will give us 2.001. 1.0001 gives us 2.0001. That means as we continue, we'll be approaching 2 eventually. So what conclusion can we draw from here? You can see that as x gets closer, and so this is closer and closer. As x gets closer and closer to 1 from the right hand side, the function f also gets closer and closer to 2. This is the same thing as we saw in the earlier part. In notation form, for this one, you can write the limit of f of x as x approaches 1 from the right hand side. So I write 1 plus. This gives me the limit as x approaches 1 from the right hand side of x squared minus 1 over x minus 1. This is giving us 2. Also, the limit of the function as x approaches 1 from the left hand side, this is equal to the limit as x approaches 1 from the left hand side of x squared minus 1 over x minus 1 is also equal to 2. Now, since both sided limits are equal, we write that since both sided limits are equal, we say that the limit of this function f of x as x approaches 1 is equal to 2. So that becomes the limit for this function. Please, I hope you all get it. Alright, so we can get a definition for limits. So for the definition, we can say the limit of a function f of x exists if and only if the one-sided limits of the function are equal. One-sided limits of the function are equal. That is to say that if I have the limit of the function f of x as x approaches a from the left hand side, if that is equal to the limit of the same function f of x as x approaches a from the right hand side, if we have the same value for that, then that becomes the limit. If they are all equal to the same number, then that is equal to the limit. It means that that function has a limit of that value. In our next video, we'll be looking at the rules of limits. So stay tuned. Make sure you like, share, and comment on this video. See you in our next video.